Right, so what we're going to do today is we're going to be using error intervals, and we're actually going to be using those to do calculations. Now, the first situation is if this person, Danny, she's got this party going on, and you want to know if there's 4 people coming, what's the minimum and maximum amount of food that they can expect. Now, the first thing that you're doing with these types of questions is you are writing those error intervals out. So for that first one, that's your error interval, okay? Now, with that being said, if you want the maximum amount of drink that each person gets, you're taking that largest number, which is 650, and you're dividing that by the number of people. So you're doing 650 divided by 4, and that's going to get you 162.5. Now, on the other hand, if you want the minimum amount of drink that they get, take the smallest amount and divide it through. And you can do that for each of these questions, okay? Now, with that being said, we're now going to work through these other questions. So, if you have a giraffe and you've got 2 of them actually, and you're measuring them to the nearest meter, what you're already doing with these questions, write it out the error interval. So for A, the largest height it can be is 6.5, but we don't include it. The smallest one, which it can be, is 5.5, and I'm measuring that to the nearest meter. For B, that's going to be, the smallest that it can be is 3.5, and it can be that. And the largest it can be, but we don't include it, is 4.5, because if we had 4.5, it would round up to 5. Now, if I'm the max difference in height, I'm taking the largest of A and the smallest of B, and I want the largest difference between the two. And I'm going to subtract the 2 of them, okay? And I get 3. Minimum difference, though, same approach, but I'm going to pick the smaller height of A and the larger of B, and I get an answer that is 1. So, if I get a situation where, for instance, both of these numbers have been rounded. Now, because they've been rounded, you've got 5 here. So 5 has been rounded to the nearest whole number, or the nearest unit, okay? So because of that, I'm going to have 4.5, I'm going to call it X, for instance, and it's going to go up to 5.5. However, if I had a situation where I had, I don't know, maybe 5.1, and because the remaining digit, or the last digit, is to 1 decimal place, my interval is going to be between 5.05 and 5.15. So it's just really careful in noticing the error interval here. So for this type of question, where you want the maximum sum of these 2 numbers, you're going to write the error intervals out for A and B. And A is the number on the left, B is the number on the right. So if you want the maximum of this calculation, take the maximum numbers, so 5.5 and 7.5, and you add them together, and you get 30. Now this is telling you that this calculation, no other number can be greater than this, because I've taken the maximum of these 2 numbers. Same approach, write the error interval out for this. So I get those 2 numbers. Now if I want the minimum of this calculation, I take the largest of B and the smallest of A, because I want the smallest difference. If I want the minimum addition, I'm taking the minimum of both of them, okay? So with that being said, I do that, I add them together, and I get 11. Now, any calculation in this using these error intervals has to be greater than or equal to 11, because I'm using my 2 minimum values that I'm allowed. Now, if I get onto a takeaway question, however, write the error interval out again. Same approach. Now, because I want the minimum of this calculation, the minimum difference, I'm taking the largest of B and the smallest of A. And I'm doing that calculation and I get that. Same approach. So if I get a maximum difference question, write the error interval out. That's what you get. And now I need to go, right, what's going to make me the greatest difference? Well, it's going to be the maximum of A and the minimum of B. And so that means that I use those 2 numbers and I get that. Now, what you might be noticing is I want you to have a quick go at this question. Pause the video and work through. It might be worth you changing the kilograms to grams. However, you can still work with this question in grams. So pause the video and have a go. Now that you've had a go at this question, the first thing that you always need to do, write the error interval out. That's that. That's in grams. If you wanted it in kilograms, though, you'd be using 4.5 up to 5.5 and you can get rid of that bit there, and you'd be using 6.5 all the way up to 7.5. Now, if you did this kind of thing, these are the calculations that you're doing. And with that being said, you might actually find this kind of table really useful for you. So that table is really handy when you're doing addition and subtraction with minimum and maximum values. So using that table, can you have a go at these questions on the right? You're definitely wanting to be looking at these questions here where you've got 1.2. So that has been rounded to 1 decimal place. So your error interval is going to be including 2 decimal places. So 1.2 is going to be 1.5, let's call it x, all the way up to 1.25, okay? Now, pause the video, have a go at these questions. Hopefully you've had a go at these questions, so these are the answers. So you should get 14, then 3.8, and so on. For E, it's worth doing the maximum bit to start with of 8.2 and 3, and then taking away the minimum of 4.5, and so on. For J, find, because you want the minimum, you're going to want the minimum of 9, the maximum of 2.2, and then the minimum of 12.5. Now, in a situation like this, where you've got a rocket, it's carrying microsatellites. The rocket has a payload of 5 kilograms, and each microsatellite weighs 300 grams. So I'm just going to change this 5 kilos to 5,000 grams. Now, because of that, I'm going to be working, if it's the nearest one significant figure, my error interval is going to be between 4,500 and 5,500. And likewise for the satellite, it's going to be that. Now, the situation that now kind of is going on is, well, if I need to safely take it out to orbit, I want the minimum payload capacity because I need to make sure that this is certain that anything smaller than this we're going to be able to use. We're not going to be able to use. So, if I have 4,500 grams as my payload capacity, I'm going to then use the largest satellite weight to go, well, how many satellites can I actually take? So I get this calculation here. Now I get 12.857. And I can't go over that capacity, okay? It's not safe if I go over that capacity. Now, the situation is, do I round up or down? I'm going to round down here. And the reason I'm rounding down is if you were to do 12 lots of 350, you end up with 4,200. And that's allowed. However, if you do 13 times 350, that's going to get you 4,550, and that exceeds the weight, so we can't use that. So the safest amount that we can use is 12. Anything up to 12.857 is fine, but you're not going to use 0.857 of a rocket. If you want the most, same approach, you do the largest capacity, and you're going to divide that by the smallest weight of the satellite, so you get that answer there. Now, if you're doing area, for instance, write the error intervals out, okay? So the error interval is, for 3, is going to be to the nearest meter. It's going to be 2.5 all the way up to 3.5. And for 5, it's going to be 4.5 all the way up to 5.5. Now, because of that, you work that out. The smallest area it has to be is you use the smallest 2 numbers. The largest it can be is you're going to use the largest, and you're going to times it by, you're going to use the largest numbers. So you get that. Now, same approach here. We want the maximum value. So I pick the 2 maximum values of the error interval. So I do 7.5 times by 2.5, and you can use your calculators in these kind of questions. So you end up with that, times those 2 together, and you get that. So that's the most it can ever be. Now, same approach. I've got 6.4 and 4.1. Now, these have been rounded to 1 decimal place. So my error interval is going to include 2 decimal places, okay? So because of that, write out my error interval. There we go. If it's the minimum multiplication, I pick my smallest 2 numbers, which are those, and I multiply those together to get that. So no other calculation using these kind of numbers in this error interval will get me a smaller number. So here we go. Now, I want to write my error interval out as per. So I get that. Now, if I want the maximum exact value, I'm going to have to pick the largest number of A, and I'm going to have to divide that by the smallest number of B. Why? Because I want to see the greatest amount. I want to see the greatest quantity that I can get. And I'm going to have to pick the largest of A and the smallest of B. So I'm going to do max divided by min. So I do that, and I'm going to get something like this. Now, in terms of rounding, the situation is going to be, well, it's a maximum. And so no other number can be greater than that. So I'm going to have to round down, okay? And I'm going to round down to 3.65 because no other number can be greater than 3.65, 116, and so on. So because we started with a maximum value and we're dividing that by the minimum, we have to round down so it's still in our error interval. Same approach, 9.2 divided by 3.4. Write out your error interval. So I get that. Now it's the minimum. So I want to be picking the numbers that get the minimum or the smallest exact value. Okay? So I'm going to have to pick my smallest of A and my largest of B. And I get that calculation. Now because I get 2.65 and so on, I'm going to have to round up. Because it has to be greater than the minimum. Like, I have to round up. So I'm going to round it to 2.66. And the reason it's 2.66 is I've got this bit here, 2173. I can't round down because that would mean that it's smaller than my minimum. And I can't have that. So I have to just round everything up. Okay? So, same approach. If I want the minimum of this calculation, granted there are two different numbers here in different scales or different units, but it's the same approach. The number on the left's been rounded to an integer and the number on the right's been rounded to one decimal place. So I get those two error intervals. Now because it's a minimum multiplication, I pick the two smallest numbers and so on. So I end up with that. Now, if I have this situation where these measurements have been taken to the nearest whole number, the maximum area for A, I'm going to pick the two maximum values of A and B, which is that. If I want the maximum length, or the minimum area, sorry, for the question on the left, I'm going to have to use the two smallest values. But when I'm doing division, I'm going to have to pick the largest of A and the smallest of B. And likewise, I'm going to have to do that for the minimum length. I'm going to have to do the smallest area divided by the largest length. So in doing that, you might start to see that this table kind of comes out. And this is a really handy table for you to be doing these questions. So you've got your help on the left. You've got the table just before on the previous slide. Have a go at these questions on the right-hand side, okay? You'll want to be using BIDMAS for E and for J, but you basically are just doing the calculation from left to right. So pause the video, have a go at that, and see how you get on. So now that you've paused the video, these are the calculations and the answers that you should get, okay? What you might be noticing for B, because you want a maximum value, is that you'll have to round down, okay? Because you've got the maximum value, you're going to want to round down, because nothing can be greater than that true value that you get. Whereas with minimum values, you're going to be eventually rounding up, because nothing can be smaller than that number that you've obtained, and so on. Okay? So, with that being said, obviously really well done for having a go at these questions. And yeah, well done. Bye-bye.